In the previous episode, we drove out to New York to pick up this second 1985 Nissan 720, where we ran into problems with the carburetor and vacuum lines. We ended up switching out the factory carburetor for a Weber carburetor using some rather questionable methods. And while this modification somehow actually worked, it was very apparent that this carburetor needed a rebuild as it was leaking raw gasoline. So in this episode, we will partially rebuild the Weber carburetor so it no longer leaks, replace some steering components, and finally we'll perform a poor man's alignment using jackstands and string. At the time that this video was filmed, Pepsi Nitro was all the rage, so of course I had to try it even though I wasn't really a soda person. Pepsi Nitro. If regular soda is canned TV static, this soda is channel 3 with the VCR on. So the rebuild kit I bought came with a number of springs, seals, and other metal components. And I've never really done a full carburetor rebuild, but I kind of have an idea of what needs to be replaced and what doesn't need to be replaced. So we're just going to replace most of these parts, but not all of them. The first order of business will be to disassemble the carburetor, which for the most part is held together with standard size screws. Based on my visual observation of the carburetor operating, most if not all of the fuel appears to be leaking from this accelerator pump. For all you Gen Z folks out there that grew up with fuel injection, the purpose of the accelerator pump is to squirt extra fuel when the pedal is depressed, usually under conditions that would require rapid acceleration. This is also the component that squirts fuel into the engine to prime it when you tap the gas pedal a couple times before a cold start. Due to its pump-like nature, it usually does consist of some kind of rubber membrane that does go bad over time. And that's exactly why this component was leaking in the first place. As I have mostly worked on fuel-injected vehicles myself, I'm not proficient in the name of all of these parts, but I'm basically going to replace any parts that I do see and recognize with the new parts in the kit. You don't need to know a whole lot about carburetors to rebuild them, but there are a few moving parts that do have to go back together a certain way, including the float and needle assembly. The float and needle actually work very similarly to the float in your toilet tank, limiting how much fuel can come into the bowl at any given time by closing off the incoming fuel supply when the bowl is full, preventing fuel from spilling down into the air intake. This bowl acts as a sort of holding tank since the fuel needs to be unpressurized for it to be drawn into the engine using the Bernoulli principle. Early fuel pumps also used a diaphragm-style movement, so the bowl filters out that intermittent supply of fuel coming to the engine. This is sort of an oversimplification of how the carburetor and the bowl within it works, but hopefully it illustrates why it is very important that it goes back together properly. The float that came with the carburetor appears to be made out of brass or a similar metal alloy, and these usually hold up just fine. However, it is more common for replacement floats to be made out of plastic. Since we'll be replacing this float, we don't have to be super careful removing it and can damage it in the process, which will make it easier to get to the pin that holds it in. We'll also remove and replace the needle while the float is out. This acts as a sort of valve that stops the fuel flow when the bowl fills up. These can and will stick open, so it's important to replace it while the carburetor is being rebuilt, even if it is okay at the time. Since the carburetor body is made of a softer aluminum, and since crush washers are provided, the replacement parts only need to be tightened gently until they are snug. I'm sure there is an exact torque spec for these parts, but with aluminum it's easy enough to feel out when they are tight. Before putting the float back in, we can install this power valve, which opens under certain low vacuum conditions to allow additional fuel into the carburetor. We can also replace this fuel line filter, which acts as a sort of last defense for any fuel contaminants that could enter the bowl and clog small components. Now we're ready to install the float. And since the float directly drives the needle up and down, the two actually get installed together and then held in place with this pin. You may need to bend the piece of metal that attaches the needle to the float in order to adjust it, but I got lucky here and it seems to operate just fine. And that's pretty much the bulk of the moving parts inside a carburetor. And since we already identified and removed the leaky component, we can go ahead and assemble the carburetor the rest of the way with high confidence that it will no longer have any issues. With the carburetor rebuilt and reinstalled on the truck, we can go ahead and replace the steering center link prior to doing an alignment. The center link links the steering mechanisms of both the left and right wheels together, which makes it one of the most important parts of the whole vehicle, as if there is any play in this component, it could greatly affect the handling of the vehicle and cause alignment issues and tire wear. There are a number of other steering components in this configuration, however those all appear to have recently been replaced. To start, we can remove the cotter pins that hold the nuts that hold the center link in, and then we can remove the nuts and brainlessly hammer away at things until the center link comes out. They do make tools to make the removal of these components easier. However, if you are patient and hammer long enough, the percussive persuasion will eventually allow the parts to come loose. It may seem counterproductive, but in this scenario, you actually hammer perpendicular to the part that you're trying to remove. Absolutely under no circumstance should you hammer on any threaded component, as this will booger up the threads and make it impossible to reassemble after replacement of the part. It may be tempting, but trust me, all you have to do is pry at the part while hammering at it from a perpendicular angle. Once the center link has been removed, the new one can be put in its place, and then everything can be bolted back together. Prior to doing the alignment, I just wanted to get a feel for how the steering felt with the new center link, and what kind of alignment adjustments will need to be made. Compared to the old center link, there was actually a lot more toe out and a lot more drag on the wheels than before, so we will absolutely need to perform an alignment before this truck can go back on major roads. At the same time, the steering did feel a lot tighter and was less likely to drift or wander. To do the alignment, we're going to use the tried and true jackstand and string technique. And before you say, uh-oh, ooga booga string and tape measure bad, laser good, hear me out. While I don't think this is the most reliable method to get a good alignment, if you follow the instructions and triple check your measurements, you can get pretty close to what a laser alignment system provides. And honestly, if you're more competent than the tech at the shop doing one of these laser alignments, it's probably better than what they can do with equipment that cost magnitudes higher than a roll of string and 2 Harbor Freight jackstands. Keep in mind that they still lay out commercial buildings with string despite there being lasers and other high-tech equipment, so it really is a case of a simple solution being the best solution to a problem. And I will admit that I've also completely eyeballed alignments using just a pair of vice grips and a wrench and just doing the trial and error method until the vehicle tracks straight. And while I can't endorse that method 100% either, honestly, as long as you can get the vehicle to track straight and you don't have any handling or safety issues, there's really no harm in this method. And really, if you're within a degree, the tire wear is going to be negligible compared to if you just let it slip out of alignment over 7 years, as I did on my F-150. So I'll try and make a quick illustration about how this method works. And there's actually a few different ways to set this up depending on your front and rear track width. The track width is the distance between the center line of two wheels on the same axle. On many cars, the front and rear track widths are going to be different, and which method you use to set up the string will be dependent on which axle has the wider track width. This Nissan 720 has a wider rear track width, which means we can use the face of the rear tires as our reference. All we have to do is tape the string to the back of the tire on the tread, and then run that string down to the front and attach it to a jackstand, making sure that the string crosses the center of both the front and rear wheel hubs. The string is straight with respect to the rear axle when it is projected across the sidewall twice without bending around the front of the tire. A straight edge like a level may aid with visual confirmation. This second method will work with virtually all vehicles regardless of the front and rear track width, but the setup will take a little bit longer. You must first know the front and rear track width values. If the track widths are the same, you can set the string the same distance from the front and rear hubs. On my 2012 F-150, which has matching front and rear widths, I like to remove the wheel's center cap to reveal a nice machined surface, which makes it easier to get a good measurement. On the front wheels, I take a measurement from the left and right of that surface along the string and average the two to eliminate any inaccuracies from the wheel being out of alignment. You can measure from the very center of the caps or hubs underneath if you are certain that they're good reference, but I prefer to use these surfaces since they are consistent on all four wheels. If your track widths are different, you will need to divide those two widths by 2 and then subtract the 2 to obtain the difference. Now it sounds a little confusing, but let's use a real-world example. On a two-wheel drive S10, the front track width is 67 inches and the rear track width is 60 inches. So we would have 33.5 and 30 inches to the vehicle's line of symmetry on each of those axles. The string will therefore need to be 3.5 inches farther from the rear wheel in order for it to project straight. Once the string on each side has been set straight using either of these methods, the procedure can begin. While making sure the steering wheel is centered, 2 measurements will be taken at the front wheel along the string using a tape measure. One measurement will be taken at the front edge of the rim and one at the rear edge. If the front measurement is greater, there is toe in, or the wheel is pointed in, and if the rear measurement is greater, you have toe out. Either of these conditions mean that the tire is dragging sideways slightly during driving, which will cause it to wear out faster than normal. The tie rod on that side of the vehicle should be adjusted until the wheel measures straight. If the 2 measurements match, then the procedure is complete on that side of the vehicle. When both sides have their own matching values, the front end should be successfully aligned. Now let's try it out on the Nissan 720. With the string laid straight across the rear tires on both sides, creating a reference line across the front axle, we can take our initial measurements. We'll measure at the front of the rim and the rear of the rim along this reference line. Then we'll adjust the turnbuckle for that side of the vehicle and then take 2 additional measurements to see if they are the same. If these measurements are not the same, we will have to continue adjusting. If the front distance is greater, this indicates toe in, and the turnbuckle should be turned to push that toe outward, and the opposite goes for if the rear measurement is greater than the front. Once the first side is reading straight, we can go to the other side and do the same thing. And if both sides have matching front and rear measurements, the procedure is complete and we can perform a test drive to see how it handles. And I must say, wow, what a difference this makes. Even if it's not laser perfect, It is certainly better than eating through tires with 2 or 3 degrees of misalignment. And honestly, like I said, if you triple or quadruple check your setup and measurements, you can probably get your alignment better than the average shop can. It all comes down to how much you care about your alignment and how much time you want to spend on it. But it certainly beats paying $139 at the local dealership, where you know they'll leave that steering wheel ever so slightly out of center every time. So now that that's all out of the way, what's next for the Nissan 720? Well, since filming this, I've been driving it quite a bit as it's been a lot more reliable. However, as I think I've mentioned in previous videos, the clutch was already pretty bad, and I think the clutch has finally decided to kick the bucket. So in a future episode, I think we'll be replacing that, and we might be doing some stuff to the interior, as I managed to score a pristine dashboard from the local junkyard among a few other parts. So tune in next time to see what we end up doing next. I really don't know what's next because I haven't filmed it yet. If regular soda is canned TV static, this soda is channel 3 with the VCR on. That's interesting. So it tastes like Pepsi, but smooth. No TV static flavor. It's Pepsi if you're tuned to a channel. A much smoother texture with the still off tastes of soda syrup.